Hello, Titan Pre-Calculus. This is Miss Cronky. I'm here for your second lesson of the week. Real quickly, I'm going to introduce what are conic sections, just very briefly, and then we're going to talk about our first conic section, which is one that you're actually familiar with, and that is the circle. So conic sections obviously have something to do with a cone, and actually, in order to produce all of the conic sections, mathematicians are going to look at something special. It's called the double napped cone. So you have a cone, two cones that share a common vertex, one on top of the other. And then the conic sections are formed by cross sections. So we've got to review a little bit of geometry here. A cross section is when you take a two-dimensional plane and you basically cut a three-dimensional object. So I'm going to go ahead and demonstrate that here for our first conic section. If I take a two-dimensional plane, a flat surface, so I'm going to go ahead and draw my plane right here, and I cut that bottom cone. If my two-dimensional plane is parallel to my base, then when I after I cut it, if I open it up and I look at the shape that's there, that's my cross section, the shape that's there is going to be a circle. So that's our first conic section. If you tilt that two-dimensional plane or you go in one side and out the base, you're going to get our other conic sections. Those we'll study later are going to be the parabola, the ellipse, and the hyperbola. Okay, so we're going to start with the circle. Now, when we look at these conic sections, we're looking at them on the coordinate plane. So we have equations for them so that we can generate points. We'll call this the standard form equation of a circle, and this is the equation of a circle that you are familiar with. EQ apostrophe N, that's just my abbreviation for equation, so I don't have to write it all out. The standard form equation for a circle is the quantity x minus h squared plus the quantity y minus k squared equals r squared. And in that equation, we have a lot of information about the circle. We know that hk as an ordered pair is going to be our center point, and we know that r is our radius. So just like a problem that you've seen before in algebra or geometry, if I give you some equation of a circle, x plus 1 quantity squared plus y minus 3 quantity squared equals 17, we have a lot of information about that circle. We know that its center point is the point -1, 3. Notice that when I answer the center point right there, the numbers look like the opposite for h and k. That's because up here in our standard form equation, they have a minus sign or subtraction in front of them, so that changes their sign in the equation. So we have -1, 3, and then just be really careful with your radius. Remember that that number on the right side of the equation, that's not actually your radius, that's your radius squared. So our radius is going to be the square root of 17. Now, I always prefer that you leave distances like that, like a radius, as an exact value. So leave it as a radical. If the radical could be simplified, go ahead and do that. But the square root of 17 doesn't simplify. When you're graphing, you might actually, though, want to think about the square root of 17, like, well, how big is that? That's a little bit more than the square root of 16, so probably something like 4.1. So if I wanted to graph or sketch this circle, I would go left 1, up 3. There's my center point. And then I'll add in some tick marks. So that I can go square root of 17, right, left, up, down, to get 4 points on the outside of my circle. So from this point, I could count 4.1 to the right. I can count 4.1 above, 4.1 to the left, 4.1 down, and then I try to draw that round shape. I've got my circle. So we're taking that conic section of the circle and we're placing it like as an equation in the coordinate plane. Now, those problems I think are going to come pretty well to you based on your experiences in, like I said, algebra or geometry. But I'm going to do an additional problem here that kind of stretches our algebraic skills and goes back to what Mrs. Homan was doing in her video with completing the square. So suppose I give you the equation x squared plus y squared plus 4x minus 6y plus 12 equals 0. And since I'm talking about circles today, I'm just going to tell you this is a circle. We'll eventually get into like how can we determine when we have all these different terms what shape that actually is. Well, Mrs. Homan, when she was rewriting, hers were all parabolas because she only had an x squared. And my equation has an x squared and a y squared. So it's not going to be a parabola like Mrs. Homan had. So, okay, I'm going to rewrite this. I'm going to actually try to write this up here like my standard form equation of a circle. So I want it to look like the quantity x minus h squared plus the quantity y minus k squared equals r squared. And so to get those groups of parentheses squared, remember in Mrs. Homan's video, she called them the square of a binomial. We're going to be completing the square to get perfect square trinomials. Okay, so go back down to my example. You can do a little bit of manipulation here. So one really great thing to do is kind of regroup things so that common like lettered terms are with each other. So I'm going to group the x's together, x squared plus 4x. I'm going to go ahead and put a plus something there because we're going to complete the square for that to create a perfect square trinomial. And then I'll have a plus y squared, and that's a minus 6y. And I need to have like that y minus k quantity squared group. So I'm going to complete the square for that as well. And I'm just going to put my plus 12 over here. Okay, and then I'll have it equal to 0. So you should be able to complete the square here. Notice that the leading coefficients to x squared and y squared are both 1. So this is not too terrible for us. So the number that completes the square for the x's, take half of 4 is 2, square it, and you'll get a 4. And in Mrs. Homan's video, she would do like a minus 4 as well to like keep the balance of her equation. What I'm going to do is I'm going to, instead of tacking that on right behind, I'm going to put it underneath my 12. Okay, so like this stuff over here with the x's, x squared plus 4x plus 4, that's my perfect square trinomial that I'll be able to write as x plus 2 quantity squared. And then this minus 4 keeps my balance. Okay, since I added 4 on the left or over here that wasn't there, I have to subtract 4 to keep it balanced. Okay, and then I'll do the same thing for the y's. So think about what number would complete the square for the y's. Take half of -6, that's -3, square it to get a positive 9. The number that completes the square is always positive. And since I just put a plus 9 there, I've got to keep that balance on the left side, so I'm going to subtract 9 over here. Okay, so, why did I do that? So that I could take these individual perfect square trinomials and rewrite them as the square of a binomial. So x squared plus 4x plus 4 will factor out to be x plus 2 times x plus 2, which I can write as x plus 2 quantity squared. And then the y squared minus 6y plus 9, this part right here, that will factor out to be y minus 3 times y minus 3, and I can write that as y minus 3 quantity squared. And then I kept the balance by subtracting those numbers that I added for completing the square. So 12 minus 4 minus 9 is going to give me a minus 1, and that equals 0. But I'm feeling pretty good because it looks like for my equation of my circle, I've kind of created that x minus h squared and the y minus k squared. The only thing is that my r squared is on the left side with my other terms. So I can obviously just add 1 to both sides. So x plus 2 quantity squared plus y minus 3 quantity squared equals 1. And there's my equation of a circle. Okay. So I know that the center of this circle is at, what would that be? -2, 3. And the radius of this circle, since I have r squared equal to 1 over here, the square root of 1 is 1. Okay. And that could be something that I graph. So we've got some problems for you to try. And of course, come to our office hours on Zoom. If you're having questions or difficulties, we'd love to see your faces and hear your voices, and we hope you're all doing well. And that's it for me. Have a great day.